This is Algebra Lesson 12.5, Expected Value. So, the expected value of a probability situation is like the average outcome. If you were to repeat a trial over and over and over and over and over again. So this will only work when we have discrete variables, meaning that they have to be numerical. Our outcomes have to be 1, 2, 3, 4, or 10, 20, 30. They can't be categorical, like this wouldn't work for red or blue or heads or tails. But the way that we do this is we have the value of the outcome and we multiply it by the probability of that outcome, and then we add together all of those answers. Now that looks kind of funny in the symbols, but it's the sum of the product of each outcome and their probabilities. But I have some wonderful tables set up that makes this process pretty simple and straightforward. So the first example says, at Berkeley City Animal Shelter, there are 25 dogs with litters of puppies. The sizes of the litters are shown in the dot plot at right. Each day, the veterinarian randomly selects a mother dog and checks the health of each of her puppies. What is the expected number of puppies to be checked tomorrow? So, X is all of my possible outcomes. So I need to know what are all of the possible number of puppies per litter. So looking at my dot plot, I could have 2, or 3, or 4, or 6. Those are my possible outcomes. None of the litters have 0, or 1, or 5, or 7 puppies. So I'm going to put all my outcomes on the top row of my table. The next row asks me for the probability of each outcome. So what's the probability that a litter has 2 puppies? I have 1, 2, 3, 4. I've observed 4 litters with 2 puppies out of the number of trials I have. I can report that as a fraction or as a decimal. If I wanted to do 4 over 25, it works out either way. And then we would multiply those together and then repeat and repeat and repeat, and then we add them up, and that would be our expected value. So let's continue along those lines. Oopsies, go back. So 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 25 of my litters have 3 puppies. And that would be 8 out of 25 of the litters have 4 puppies. And 3 out of 25 of the litters have 6 puppies. And if we do 2 times 4 divided by 25, we get 0.32. And 3 times 9 divided by 25, we get 1.08. And 4 times 8 divided by 25, 128. And 6 by 3 over 25, 0.72. Then for my final answer, I need to add the bottom row. And I get 3.4. So the expected value, also known as the average outcome, is 3.4 puppies per litter. We have one more example, basically the same setup though. A fair 6-sided die is rolled. If the number showing is even, you lose a point for each dot showing. If the number is odd, you win a point for each dot showing. Find the expected value for one roll. So I need the possible outcomes. So when you're rolling a die, you can get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. But we're going to get a little more specific. If it's an odd, that means I win. So all my odds are winning. If it's even, you lose, so all my evens are losing. The probability of rolling any side on a die is always 1/6. So rather than write those all out, I'll get a little lazy. But we're going to do the same process from above. We're going to multiply each of these. I'm rounding to the nearest thousandth. So that was 1 times 1/6, -2 times 1/6, +3 times 1/6, and so on. And then we're just going to add all of these values together from the bottom row, and that is my expected value. So if I play this game, I am expected to lose half a point. Now if I played this game 10 times, I would expect to lose half a point every single time I play it. Sometimes we're going to win 5, sometimes we're going to lose 6, but the average is we're going to lose 0.5 every time. So if we multiply that by the 10 times we're going to play, in the end we end up losing 5 points. That is it for the notes for this lesson. Good luck on the exercises, and please let me know if you have any questions.